Okay, last section notes for chapter 11. Mostly going to talk about word problems. Do have a little bit of review. To start, we're going to write explicit and recursive rules for a sequence. Again, looking at a sequence, it's all about finding a pattern. If we look at the first one, how am I getting to the next term? If I see, okay, again, thinking adding, subtracting, or multiplying, dividing, I see plus 6 works to get to that next term. Therefore, meaning it is a arithmetic. And again, for the explicit rule, a sub n is equal to dn plus a0. For the recursive, it's going to be define a1, and a sub n is equal to a sub n minus 1, which is referring to the previous term, plus that common difference. So for the explicit rule, a sub n is equal to dn, which is that common difference, which is that 6n, plus a sub 0, working backwards, just subtract 6, and we get minus 5. So plus negative 5, which I'll just write as minus 5. For the recursive, again, define a sub 1, which in this case is 1, and then a sub n is equal to a sub n minus 1 plus that common difference, which is 6 in this case, so plus 6. Moving to the next one. Okay, I see adding and subtracting is not going to work, so I'm thinking divide by 3, divide by 3, divide by 3, but then again, in geometric, we need to think of it as multiplication, so dividing by 3 is the same as multiplying by 1/3, so we have a common ratio of 1/3. And writing explicit rules, we get a sub n is equal to a sub 1 times our common ratio, n minus 1. If we were talking about recursive, again, define a sub 1, a sub n is equal to a sub n minus 1, again referring to the previous term, times their common ratio. So let's do our explicit rule. We get a sub n is equal to the first term, which in this case is 36, times that common ratio of 1/3 to the n minus 1. Doing our recursive, defining that first term of 36, and then a sub n is equal to a sub n minus 1 times that common ratio of 1/3. And again, you can have it as 1/3 times a sub n minus 1. Either way works. Yep. So then, looking to get the first 5 terms of a recursive, given a recursive rule, we're going to, if we're given a sub 0, again, recursive rules, we are building off a previous term, so we have 2. So then a sub 1, meaning we're using n squared, which n in this case is 1, so we're saying 1 squared, minus the previous term, because a sub n minus 1 is referring to the previous term, in this case is 2, plus 3, meaning 1 minus 2 plus 3, which will give me 2. So then again, a2, we're doing 2 squared, because my n is 2, minus a sub n minus 1, referring to the previous term, so minus 2 plus 3 equals 4, minus 2 plus 3, or 5. 3 squared minus 5, because we're subtracting the previous term, plus 3, 9 minus 5 plus 3, which is 7. Then 4 squared minus 7 plus 3, so 16 minus 7 plus 3, or a total of 12. So big thing, just remember a sub n minus 1, meaning the previous term of where you are. Okay, there's our review. Going through some word problems. Pendulum swings 10 feet going left to right. On its swing back, it swings 90% as far as the first swing. Each successive swing is 90% of its previous swing. We have done this problem already. I do want to go over it a little bit better. So if we imagine pendulum, okay, and it's going to go this way, and then it's going to come back, and it's going to go 90%, and then 90% of that, 90% of that. When we do this, to get 90% of something, we are multiplying by that value. And again, 90% is equal to 0.9. So then you got to think about that first swing, which would be the first term, is going 10 feet. And then if we go 90% of that, that's going to be 9 feet. And if we go 90% of that, that's going to be 8.1. And it's going to just keep going and keep going and going and going and going. Okay. So now to find the total distance traveled by the pendulum when it finally stops, we're thinking we don't think that it's going to stop. So this is infinite. So an infinite geometric series since we are multiplying. So then again, that ratio is 0.9. The first term is 10. And then since it's an infinite geometric that has a ratio that's between -1 and 1, this sum is equal to the first term over 1 minus r, or 10 divided by 1 minus 0.9, which we found was 100 feet. So the pendulum will finally stop after 100 feet. And it's going to start moving to a point where it's basically not moving, and in real life it is stopped. Now again, when will the pendulum travel 50% of its total distance? We have a total distance of 100 feet, meaning a distance of 50. That is the sum. And since at this point, we're asking for it to stop at some point. When does it reach 50? So now it has moved from a infinite geometric series to a finite geometric series. So if you remember, S sub n is equal to a1 times 1 minus r to the n over 1 minus r. Now it has shifted from the s is equal to a1 over 1 minus r to now this. And we are given the specific sum, which is 50. And the first term has not changed. Our ratio has not changed. We just don't know n in this case. And again, divide by 10. Divide by 10. We get 5 is equal to 1 minus 0.9 to the n over 0.1. Multiplying by that 0.1. We get 0.5 is equal to 1 minus 0.9 to the n. Subtracting the 1 over, we get negative 0.5 equal to negative 0.9 to the n, or 0.5 is equal to 0.9 to the n. Rewriting it, because again, logs are the inverse operation of exponentials. We get log of 0.9, log base 0.9 of 0.5 is equal to n, which n is equivalent to about 6.6. Meaning, this answer, to travel 50 feet, the pendulum is going to do about 6.6 back and forth. So 1, 2, 3, 4, 5, 6, and then about a little over halfway on that next swing is when it will reach 50 total feet. Okay, this was how we started off the whole chapter. You start a new job that will pay you a penny on the first day, and then double your pay every day after. How much will you get paid on the 7th day, the 14th day, and the 30th day, and then how much did you make that month? The fact that your pay is doubling, that means we are multiplying by 2, meaning we have a ratio of 2, and we have a first term of 0.01. And since we are multiplying to get to that next term, this is a case where we have a geometric sequence. So we have an explicit rule of a sub n is equal to 0.01 times 2 to the n minus 1. Now, since it's asking for how much we get paid on the 7th day, that case it's asking for a sub 7, so 0.01 times 2 to the 7 minus 1, or 0.01 times 2 to the 6, which will give me a total of 4 cents. That is how much we will get paid on the 7th day. Okay, moving to the 14th day, that's asking for the 14th term of this sequence. So 0.01 times 2 to the 14 minus 1. Or 0.01 times 2 to the 13th. Which ends up giving me $81.92. So our pay is getting gradually better as we go. Now think about the 30th day. You got 0.01 times 2 to the 30 minus 1, or 0.01 times 2 to the 29th, for a total of $5,368,709.12. Pretty good payday for one day. Now, when it's asking the last question, how much did you make that month? That's asking for the sum of all the days. So in this case, we are finding S sub 30. And since it is geometric, that is where we have A1, which in this case is 0.01, times 1 minus the ratio, which is 2 to the 30th, over 1 minus 2, which will give me a total of $10,737,418.23. So if I were you, I would definitely take this new job, because just think, it's doubling after that fact as well. Okay, as a farmer bales a field of hay, each trip around the field gets shorter. On the first trip around the field, there were 230 bales of hay. So that's going to be my first term. It gets 230. On the second trip, there were 219. The number of bales each succeeding trip decreases arithmetically. So the fact that it's saying arithmetically, it means we're adding or subtracting. Therefore, we can figure out a common difference. So to get from 230 to 219, we are subtracting 11. So 208 would be the next one. And I can keep going with that by subtracting 11. Get a common difference of negative 11. So now it goes up until A10. So the question is, how many bales of hay does the farmer get from the field? So we are finding S sub 10 since there's 10 total trips. Now you could go ahead, find all 10 terms, add them up. It's going to take a little while. A little bit easier is just using the formula. Since we're going to have A sub n is equal to negative 11n plus 241, because I'm getting that from A sub n is equal to dn plus A0. And again, knowing that explicit rule is typically going to help you at any point throughout this whole process of solving word problems. And again, finding the sum of an arithmetic series, that's that n over 2. So 10 over 2 in this case, times the first term, which is 230, plus, in this case, A sub 10, which we still need to find, which is why our explicit rule will help. So we need to find A10, meaning negative 11 times 10 plus 241, which gives me a total of 131. So I'm going to go on and replace that A sub 10 with that. 10 over 2 times 230 plus 131 to give me a total of 1,805 bales. So again, finding the sum of an arithmetic series S sub n is equal to n over 2 times a1 plus a sub n. In our case, we were finding s sub 10, so that is why we were finding a10 in that case. And just plugging in your first term, and the value for n. Just do really want to emphasize finding the explicit rule with any word problem is going to help you at some point. So make sure to find the explicit rule anytime I give you a word problem. Last one. Your father wants to make a deal. He will give you 5 cents to clean the garage. He will then double the amount daily for each day this month that you keep the garage tidy. Today is August 15th. Is it a good idea to accept these conditions? How much will you earn on August 31st? So, first day, we get 5 cents. Okay, you could do this as 0.05 or 5 and just realize that you are in terms of cents. Let's just go with 5, make things a little easier. And then we are doubling our pay every day after that, so on and so forth. The fact that we're doubling tells us that we are geometric. Therefore, I can write an explicit rule again. First term of 5, common ratio of 2, because since we are doubling, there's our explicit rule. So, today is August 15th. Is it a good idea to accept these conditions? How much will you earn on August 31st? August 31st compared to August 15th. That would be the 16th day, meaning we want to find the 16th term of the sequence. So 5 times 2 to the 16 minus 1, or 5 times 2 to the 15th, which will give us 163,840. And again, we need to remember we did not put it in terms of actual 0.01 for a percent. So just changing this to dollar amount, we get $1,638.40. If I were you and my dad was making this deal, I would definitely make that deal, since you need to remember this is how much you're making on a single day on August 31st, not counting the previous days that you've earned. So again, I didn't do this in terms of cents until the very end. In this case, the previous one, I did it in terms of cents. You can use that same idea on this one and just have a first term of 1. Either way, if you go that route, you need to make sure to put it in terms of dollars and cents in the end. Those are our word problems. There are word problems throughout all the assignments. Now you should be able to go back and work through those on your homework assignments. As for this one, you are to do worksheet 11.5 word problems for this assignment. Other than that, have a good day.